This is something we worked on earlier in the year, so this will be a little bit of review. Hopefully it will come back to you. So we start out with iron 2+, and iron 2+ is oxidized to iron 3+. So we're just told that in the instructions. We add an electron to balance the charge so that we get the same charge, in this case 2+, on both sides of the equation. Next, we will take the MnO4-, which is the oxidizing agent, and this you actually wouldn't be expected to have memorized, but MnO4- is reduced to Mn2+. So the next step is to balance the atoms, and we balance the atoms first of all by adding water. So because we need 4 oxygens, we're going to use 4 H2O. And then we're told that the reaction is in acidic solution, so we can add 8H+ on the left side of the equation. So now we have all of the atoms balanced, we just need to get the charge balance. So on the right side we have a 2+, so over here we have 2+, and then on this side we have 8 H+'s, and then we have a minus, so that's going to give us a total of 7 pluses, and then we want to bring that down to the same amount that we have over on the other side. Okay, at this point we have the two half reactions balanced independently, and we want to balance the transfer of electrons from one half reaction to the other. So because on this side we have 5, or in this half reaction we have 5, and in this half reaction we just have 1, then what we want to do is multiply this reaction by 5. Now we can add everything together and we'll cancel out what is common from one side to the other. Alright, so we have first of all 5Fe2+, and we have 8H+, we have MnO4-, then on the other side we have 5Fe3+, and we have Mn2+ plus 4H2O. So if we check, everything should be balanced. So let's do that. Let's check the oxygen. So we have 4 oxygens on this side, and we have 4 on this side. We have 8 hydrogens on the left side, and we have 8 hydrogens on the right side, and we can see that everything else is balanced. In terms of the charge, we have 5 times 3, which is 15, plus 2, so that's a total of 17 on the right side. On the left side, we have 10 plus another 8, so that's 18, and then minus 1. So that gives us the overall equation that we were looking for. So let's just finish up and mention the terminology. So what we would say is that the iron is being oxidized by the permanganate ion, that's the MnO4. So the permanganate ion is the oxidizing agent, and the iron is being oxidized, as we said, so you can also think of the iron 2+ as being the reducing agent. Okay, so let's take a look at another one. Again, we have the MnO4-, the permanganate ion is the oxidizing agent, so it's going to go to Mn2+, and we're going to have 4H2O. So this is the same as what we had previously. Then for the oxalic acid, that one is like this, and that goes to CO2. So you wouldn't be expected to memorize that. This is just something that you would be given. And we can balance the carbons and the oxygens by putting a 2 here, and we can balance the hydrogens by putting 2H+ because we know it's in acidic solution. So now we have 2 H+'s on the right side of the equation, so we'll get the charge balance by adding 2 electrons. So we have in the first reaction the reduction of the permanganate ion, that's gaining 5 electrons. And the second reaction is giving up or producing 2 electrons. So to balance the electrons transferred, we'll put a 2 there, and we'll put a 5 here. And now we can multiply through and just cancel out where we need to. So we'll start here. So this is going to be 16H plus 2 MnO4 minus plus 5 H2C2O4 yields 2 Mn2 plus 8 H2O, and then we're going to have 10 CO2, and finally we're going to have 10 H plus. So the only thing that we need to do is we've got 16 H pluses there, and we've got 10 over here, so we can just subtract that, and that will leave us with 6 H pluses.